Hello, ladies and gentlemen. Today we are going to be covering, if I share my screen here, we are going to be comparing proper fractions. Proper fractions. So as we begin this lesson, I encourage you to pause this video at this point and to take your time to copy this down, which is simply the heading. Comparing proper fractions. SB 4-2, comparing proper fractions. This is our 7th lesson. And these are the numbers that we will be doing for our assignment. And by the way, we're going to be doing most, if not all of those in this actual recording. So I highly encourage you to obviously not only write down the heading, but to have this handy as we go and do the actual, we get through the lesson. Now, not every example that we have in the lesson is going to be one of our problems, but a lot of them will. For those of you who are having a hard time reading my handwriting, I'm going to type it up here for you. So this reads, comparing proper fractions. And so again, I encourage you to pause the video at this point and copy this down. And once you're ready to move on, then you may move on. Okay, assuming you've copied the heading down, let's begin with this simple example of a fraction. Since we're going to be comparing fractions, specifically proper fractions, let's begin with a proper fraction. And we're not going to be defining a proper fraction just yet, but I will refer back to this whenever we start talking about proper and improper fractions. So let's begin with the fraction 3/10, or 3/10, as some would say. So 3/10, 3/10. We must know that the top number is known as the numerator. The top number is known as the numerator, and the bottom number is known, there we go, and the bottom number is known as the denominator. Make that a little darker. So again, we have the top number, the first number is known as the numerator, whereas the second number is known as the bottom number is called the denominator. What do each of these actually mean, though? I know that the top number is the numerator. I know that the bottom number is the denominator, but what do these actually mean? Well, the numerator, the top number, always tells us how many parts we have. How many parts you have, or how many parts you're given, or just notice how it's part. It's not the whole thing. It's a certain part. It's a section of the whole. And the second number, the denominator, tells us how many parts make a whole. How many parts? So how many of the top ones you need to make, how many of those pieces you need to make a whole of something. So once again, and I encourage you to pause this as you copy this down. Please have this in your notebook. So again, we have a fraction that is 3/10, or 3/10. The top number is known as the numerator. The bottom number is known as the denominator. And I have those written down here. And the numerator, the top number, tells us how many parts we have, or how many pieces we have out of a whole. And the denominator tells us how many of those pieces on top we actually need to make a whole of something. All right. Again, pause it, copy this down, and then come back and let's continue. And so to make my point, I'm going to use pizzas. I like using pizzas. I think pizzas are one of the best ways to think about fractions. And I realize that pizzas are usually cut into 8 pieces. But this first pizza that I'm going to make, I'm going to cut into 10 pieces for simplicity's sake. So let me make this smaller for now. We'll come back to this in a second. Sorry. And there we go. Let's make this as small as possible. Okay. And let's begin with a pizza. And we'll make this pizza pink. Okay. So here's our first pizza. And this pizza, like I said, we're going to cut into 10 equal slices. And so I'm going to do my best. So now it's 2 slices, right? And so let's make 5 on each side. So that's 5 slices on each side, on this side. Okay. And let's do 5 more slices on this side. And ideally, these slices are all the exact same size. I know they look pretty close, but for the sake of this example, these are all going to be the exact same size. And as you can see, we are going to fill in 3 out of those 10. So I'm going to shade in 1, 2, 3. So let's suppose that you go to a gathering or you go to a pizza party, of course, and they give you 3 out of 10 slices. So that is your section. This whole section right here, this is the section of the pizza that they gave to you. You're like, okay, it's a pretty sizable portion. All right. However, your friend comes with you, and to your friend, they ran out of this pizza, so they're going to give him from a different one. And this pizza, so let me make a pizza that is of the same size. They're going to use the exact same amount of dough. And so let's just make it around the same size. However, this pizza, for some reason, they decided to cut it into 8ths, like a traditional pizza. So let's cut this into, here's 2 pieces. They realized that it's actually a lot easier to cut into 8ths than it is to cut into 10ths. And again, for our purposes, we're going to assume that every single slice is the exact same size. And they wanted to, these people didn't know a lot of math, let's just suppose, and they wanted to give him the same amount of pieces they gave you. So they're like, well, we're going to give him 3 pieces as well. So 1, 2, 3. And so essentially they gave him this whole section. And notice it looks very similar in size as yours, but it's not exactly the same when you think about it. And so then they gave him 3 out of the 8 total slices that there were. Okay. And now let's get a little ridiculous. So now let's say that you brought another friend, and this friend, so they took out another pizza, and this pizza, let's make it, purple's fine. All right, so this, we're gonna make another pizza, is gonna be the exact same size. So the same amount of dough. However, they're gonna cut this pizza a little bit differently. In fact, they're gonna cut this pizza into not 4 pieces, not 8 pieces, but, so that's 8 pieces. That is 16 pieces. All right, so if you were to count it, that is 16 pieces, but we're actually gonna go even further. Let me see if I can even do this. I'm just gonna do my best as we should, right? We're actually gonna cut it into 32s. All right, you get the idea. And so for some reason, they were like, man, we're running out of pizza, but we need to give everybody 3 slices. And so they cut their pizza into 32s, and they gave your friend 3 slices. And they're like, yeah, we want to give you the same amount, the same number of pieces. So we're going to give you 3 slices. However, that is 3 out of 32 slices. Okay, now let me ask you this question, which is kind of obvious. Did you guys each receive the same number of pieces? Yeah, you did. You each received 3 pieces. However, did you receive the same amount of pizza? Think about it. Is this piece, the 3/10, the same as the 3/8, the same as the 3/32? No, it's not. These pieces are all actually, these sections are all very different from one another, right? And that's precisely my point, that just because you get the same number of pieces, what really matters in this case is not the number of pieces that you get, but rather how many pieces the whole pizza was cut into. All right? If you want to get more extreme, let's say that they cut a pizza into 100 pieces and they gave your friend 3 of those little pizza vitamins. They're tiny little pieces. You need 100 of them to make a whole pizza. Well, over here, you only need 10 of them to make a whole pizza. So there's a huge difference in the pieces. So as we see in fractions, the pizzas are the same size in this case. The only thing that changed was the number of pieces that I cut my pizza, the equal pieces that I cut my pizza into. So with that in mind, let's move into the actual problems. Let's move into the first actual problem in our assignment. So let me clear this page and let's zoom in. So for those of you that don't know exactly where I'm at, I'm actually working out of, so you should have your OneNote open. So if you haven't, then pause this video and open up your OneNote, go to the classwork tab and then go down to where it says 4-2. And actually, let me open my teacher one. Teacher only, classwork. For some reason, it's not coming up. So let me try a different period. Let's try first period. Okay, so again, open up your OneNote. Go to your name. Go to classwork. And open up 4-2, comparing and ordering fractions. And we're going to begin with number 4 as soon as this loads. We're going to begin with number 4. And I don't know why this is not loading. There we go. Number 4. All right, and I circled it already. So number 4, let's read it together. So in an election, so it's referring to an election that they were doing in the previous problems, in Mr. Fair's homeroom, Andy received 5/23 of the total votes. Betty received 7 out of 23 of the total votes. And Shanetta received 8 out of 23 of the total votes. And Dion received 3 out of 23 of the total. Which candidate was elected? Explain how you know. Let's first circle our important information. Yes? So let's go to draw. And let's circle what is important. So obviously, Andy is so they're having an election of some sort, and Andy here received 5 out of 23 of the votes. Okay, so we know that there's a total of 23. So if the fraction is 5/23, then the part that he received was 5. Remember, part is the numerator. Out of the whole, or how many pieces you need to have the whole classroom, 23. 23 people in that class. Betty received 7/23 of the total. Shanetta received 8/23 of the total, and Dion received 3/23 of the total. And we want to see who got the most votes. And so that's precisely where I got this information over here in my notebook. So we have Andy, and we're going to call Andy. A. So Andy, we're just going to call him A. He received 5 out of 23. That's where that fraction came from. Betty, we're going to call her B. She received 7 out of 23. So out of those 23 total people that could vote, 7 of those chose Betty. For Shanetta, we're just calling her C. She received 8 out of 23 votes. And Dion, we call him D. It's a D. He received 3 out of the 23 total votes. So unlike the example that I gave you with the pizzas, where the numerator was always the same, 3, 3, and 3, but the denominators were different, here, as you can see, the denominator is exactly the same. That means that we're using, if you will, if this were a pizza, we're comparing pizzas of the same number of pieces. So in this case, we can actually look at the numerator to compare this. We can easily see that the person that received the most votes was actually Shanetta, because she received 8 out of 23. That would be the same as if all the pizzas in our original example were the same size and somebody received 1 out of 8 pieces, another person received 3 out of 8 pieces, another person received 5 out of 8 pieces. All right, who received the most number of pieces? Who received the most pizza in this case would be 5. And we know that that is the most pizza because all of those pieces are the exact same size. They're all out of 8. They're all out of a total of 8 pieces. So in this case, the classroom, it's the same classroom. So each fraction is taken from the same pool, if you will. And it's easy to see that Shanetta, with 8 out of 23, got the most number of votes. And by the way, that would be the answer to number 4, who got the most number of votes. So Shanetta would be the answer. That's what you would put on Schoology, Shanetta. Okay, so moving on. Number 5, you can do on your own. You're just gonna answer that question. But let's move on to number 6 and 7. We have a little bit of a different example here. So let's go ahead and let's read the passage that will lead us to numbers 5, 6, and 7. So the 300 students, I'm reading from right here, the 300 students at West Middle School held a traditional election for student council officers. Eden, Frank, Gabrielle, and Hernando ran for president. Eden received 4/15 of the votes. Frank received 3/10. Gabrielle received 1/30, and Hernando received 2/5. So let's get the important information. So Eden got 4/15, okay? Oh, and before even that, there's 300 total students. That's important. And out of those students, Eden received 4/15 of their votes. Frank received 3/10 of their votes. Gabrielle received 1/30 of the votes, and Hernando received 2/5. All right? So here's the problem, though, and let's go to the actual, notice how I wrote these down. So again, we have Eden. I'm gonna just call her E. So Eden received, so this is Eden. Eden received 4/15, so 4 out of 15. Interesting. Frank received, so I want to put an F for Frank, 3 out of 10 votes. Okay. Gabrielle received, so G for Gabrielle, 1 out of 30 or 1/30 of the votes. And Hernando, we'll put H for Hernando. Hernando received 2/5 of the votes. Here's the problem, though, and you might be wondering, Mr. Lugo, I thought that the denominator told us how many pieces we needed to make a whole, and I thought that the total number of students was 300 students. So how is it that Eden received 4 out of 15? I thought it would be 4 out of 300. Why is it 4 out of 15 and not out of 4 out of 300? Well, ladies and gentlemen, we have to understand that when we're working with fractions, you can simplify a fraction. In other words, you can have different numbers and still be saying the same thing. For example, let's go back to the pizza example. Okay, so let me make 3 pizzas. Again, let's just make them all in red. That's fine. Where's my pizza tool? All right, so we're gonna have 3 pizzas. So you have 1 pizza, 2 pizzas, and we'll make our 3rd pizza over here, 3 pizzas. And let's just assume that these are the same size. I know they're not exactly the same. Let's just assume they're the same size. And so for my first pizza, let's cut this pizza into 2 pieces. That's it. You were just sharing it with your brother or sister or cousin or whatever, and you just cut this straight down the middle because you're like, we might as well. We're only going to have 2. All right. And so one of them is for you. And that's not what I wanted to do. One of them is for you, and the other one is for your cousin, okay? And so in this other scenario, we're gonna have, let's just suppose that you thought pieces were too big, and so you're like, well, let's make them a little smaller. So the next week, you actually cut the pizzas. So you buy the same pizza, and you end up cutting it into 4. So you're like, well, it's still just 2 of us, so I'm gonna have 1/2 of it, and you're gonna have the other half. All right. And in the third scenario, let's just say that you still thought those were way too big and it was just really hard to eat them. And so you're going to cut the pizza into 8 pieces, like a traditional pizza. And you realize, you know what, those pieces really are the best size. Now, in each scenario, we're cutting the pizza into different number of slices, but since you're just sharing it with one other person, each of you is going to get half. So in the first one, since there's 2 pieces, so the fraction would be out of 2, and you're going to get 1 out of those 2 pieces. So this is going to be your share of the pizza. You're going to get 1 piece out of 2 total pieces. All right, so you're getting half the pizza. In the second scenario, same thing. You're only sharing with one other person. You want to have the same amount of pizza, so you want to have the same number of pieces. All right, so you're going to get 2 of those pieces, 1, 2. or 2 out of 4 pieces necessary to make a whole now, because we cut it into 4 pieces now, right? And in the third scenario, again, this time you're going to receive 1, 2, 3, 4 of those pieces, or 4 out of a total of 8 pieces. Now let me ask you this. In which scenario did you receive the most pizza? In which scenario did you receive the most amount of pizza? Not slices of pizza, but amount of pizza. Well, just by looking at it, you can see that in each scenario, ladies and gentlemen, we have the exact same amount of pizza. In each time, if you really want to keep it as simple as possible, you're getting half of the pizza. The simplest way of saying 4/8 is 1/2. The simplest way of saying 2/4 is 1/2. 1/2 is half the pizza. So we know that 1/2, 2/4, and 4/8 are all exactly the same thing. But the simplest way of showing something like 4/8 is 1/2. So going back to our election, not that any of these people got this many votes, but if anybody got half the votes, they would literally get 150 out of 300 of the votes. But an easy way to say that would be 1/2. That would be the simplest way of saying that. And so sometimes when we're using fractions, we use the simplest version of the fraction. And in this case, that's going to be 1/2. Okay? And so as you can see, even though I'm using different numbers, I can see how these are all exactly the same. 1/2 is the same as 2/4, same as 4/8, which is the same thing as 150 over 300. All of these would represent halves. If I were to cut my pizza into 300 little pieces, if you want half of it, you would end up with 150 of them. That's precisely what I'm saying. All right, so with that in mind, let's go back to this example. Because okay, sorry. All right. Now, and this isn't exactly what the problem is asking to do, but I want you to entertain this idea really, really quickly. Do it with me. So in this case, the easiest one to see this in is actually Gabriel, because we have Gabriel with 1 out of 30. All right. But I know that to make it back into terms of 300, I know that 30 times 10 is 300. So 1 times 10 is going to give me 10 out of 300. So that's literally how many votes she had. She got 10 out of 300 votes. If we go up to Eden, again, we want to see over out of 300. 15 times what gives you 300? I believe 15 times 6. 30. Yes, I'm pretty sure 15. I can't even think right now. It's like late in the day here. Yes, 15 times 6. So 4 times 6. Let me just double check on that. 6 times 5 is 30. No, 6. I can't even think. That was not even right. That was nowhere even close. Give me 1 second. So let's just divide 300 by 15. That's going to be the easiest thing to do. By 15, that goes into it twice. 15 times 2 is 30. 0, 20. Not even close. I can't even think. All right. So scratch that. I was completely off. It is late in the day while I make this video, so I can't even think straight. So this was for my own doing. That's what I get for doing this video so late. Anyways, so we know that 15 times 20, that makes a lot more sense. I don't even know what I was thinking, is 300. So 4 times 20 is going to be 80. So Eden received 80 of the votes. Okay? That's exactly how many votes she received. For Frank, 10 times 30 is going to be 300. So 3 times 30, notice how I'm both, on the numerator and the denominator, I'm both increasing them by the same factor, by the same amount. I'm literally multiplying by the same amount. So 3 times 30 is 90. So he received 90 out of 300 of the votes. And Hernando, we have 5. 5 times what gives you 300? I would believe it's 60. So Hernando received, so 2 times 60 is 120, 120 out of the 300 votes. So really what they did is they simplified each of these fractions, 80 out of 300, 90 out of 300, 10 out of 300, 120 out of 300 to make these simpler fractions with smaller numbers. Now, it may not make a lot of sense in this specific example, but I want you to see how in the real world, a lot of times we'll take a complicated fraction, because we rarely get numbers that are nice and round like 300 in the real world, and we make it into simpler fractions because it's really a lot easier to say 3/10, he got 3/10 of the vote, as opposed to he got 90 out of 300, okay? Because a lot of times we use a lot bigger numbers than even those, and it's easier to say about 3/10 or 3/10, okay? So just by looking at this, we can see that obviously Hernando, what seemed like one of the smaller fractions, actually he received the most votes. However, if we look at the problem, we're going to see that that's actually not what the question is asking. So number 6 is asking, what is the least common denominator, the fraction of votes received in West Middle School election? Least common denominator. What does least common denominator actually mean? Okay, so obviously right here, they don't have the same denominator. We have 15, we have 10, we have 30, and we have 5, right? The original denominator really is 300, okay? But when I simplified it, we realized we ended up with a whole bunch of different fractions, which made it hard to tell which was who was the winner, okay? What I'm saying is that, and notice how it was even hard for me to figure out what I have to multiply it to get it back to 300. So what we can do, ladies and gentlemen, is actually find, instead of trying to get all of these to equal 300 again, we can find what is known as the least common denominator, or LCD, as you'll see it sometimes. It's called the least common denominator, or LCD. And feel free to write that in your notes, actually. I didn't type it up for you, I didn't write it up for you, but that means least common denominator. The least common denominator. LCD. So what we're saying there, guys, is that we're going to look at each of these denominators. We're going to look at 15, 10, 30, and 5, and see if there's a number that they have in common. Okay? For example, and I'm going to see if I can make them equal 30, and if not, if there's a number that they'll have in common. All right? So right here, I know they all seem to fit into 30 because 5 times 6 is equal to 30, right? And then 10 times 3 is equal to 30, and 15 times 2 is equal to 30. So I can see that 30 is actually a common denominator for all of them, okay? So 5 times 6 is going to be 30, but whatever I multiply a denominator by, I must also multiply the numerator by. I must increase the numerator by the same factor. So if I'm increasing the denominator by 6, I need to increase the numerator, the top number, by 6. So 2 times 6 is going to be 12. So it's going to be 12 out of 30. Okay. Gabrielle is 1 out of 30, so we're just going to leave it like that, 1/30. It already has the denominator. So I'm going to multiply both of these by 3. So 3 times 3 is 9. 10 times 3 is 30. So now they have the same denominator. And then 15 times 2 is 30. And 4 times 2 is going to be 8. 8 out of 30. Okay, so we have 8/30, 9/30, 1/30, and 12/30. Notice that here in this scenario, now that they have the same denominator, just like it was easy to tell who had the most pizza whenever we're working with only 8 pieces in each of the 3 pizzas, right here, because they all have the same denominator, I can easily tell that Hernando got the most votes. He got 12 out of 30. Okay? Instead of having to go all the way to 300, where this was 120 over 300, 10 out of 300, 90 over 380, this is a simpler version of that. And so the least common denominator was 30. And whenever I made them all to be under over 30, I could easily see which one was got the most votes, which in this case was Hernando. So I realize this is a little confusing. I encourage you to go back and rewind and watch this again. Maybe it's going to make a little more sense, but let's move on with the assignment since I want to do most of it with you, if not all of it. So now I'm going to clear this up. So we found, again, number 6, the denominator, least common denominator was 30. And when we did that, we got these fractions, which is exactly what I had in my notebook, where this was 8 out of 30, 1 out of 30, 9 out of 30, and this was 12 out of 30. And that's how we did that. All right, moving on. What is the next numbers that we have to do? And because we didn't do a lot of these in class, I do want to get through some of these. So we're going to go all the way through number 10. So number 8, write the fractions in order from least to greatest. So you're going to take those fractions or these fractions. And now that you know now that you have your least common denominator, you'll be able to tell which is which from least to greatest. Okay. Number 9, Nathaniel ordered the fractions in item 7. So number 7 from least to greatest after finding the equivalent fractions with the denominator of 300. Just like what we did the first time. Remember when we put them over 300? Do you think Nathaniel's method is less difficult or more difficult than the method you used to order fractions? Now, if you saw, I actually made a mistake. I made a legitimate mistake. Yes, I realize I'm tired. When I was putting them over 300. I think it depends on the person. Some people might actually think it's easier, but generally speaking, it's actually the bigger the denominator, even if they all have the same denominator, the more difficult it's going to be. So if you have a least common denominator as opposed to just a common denominator like 300, we use 30 instead. I think it's a lot easier to do that. And then now number 10, list the candidates in order from first place to fourth place. Now I just put the names in the candidates. Cool, pretty simple, pretty simple. All right, let's move on to number 14. 14, and I believe that is actually in my other notebook, yes. Now, before we actually do number 14, I'm going to teach you another method of comparing fractions, okay? We're going to, even though number 13 is not one of our assigned numbers, I don't believe. Yes, it is. Number 13 is. Scratch that. Let's do number 13. Good. That's why I wrote it down here. That makes total sense. So let's move on to number 13. So all I did is I copied number 13 onto my notebook, and we're asking ourselves, which of these two is greater? And we're going to use the greater than or less than symbol to express this. So we're just going to say which of these two is greater than the other. Excuse me, greater than or less than. Okay, so let me zoom in yet a little bit more. Okay. And now there's two ways of doing this. Number one, like we already saw, we could make sure they have the same denominator. And so here it's actually pretty simple because I know that 8 times 2 is going to give me 16. All right. And so I can multiply the numerator by 2 as well. You always multiply them by the same factor. And so 5/8 is actually going to be the same thing as 10/16. And so just by doing that, I know that 10/16 is more than 9/16. So that means that 5/8 is greater than 9/16. That was actually pretty simple. However, there is another method that it will be easier for problems where it's not as obvious what the common denominator is. Okay, and that method sometimes I hear referred to as the butterfly method, but today we're going to refer to as cross multiplication. And feel free to write that into your notes, into your assignment, cross multiplication. And what cross multiplication says, ladies and gentlemen, is that when you multiply the denominator, so we're going to multiply across, hence the word cross. So I'm going to multiply 16 times 5. So I'm going to multiply that way. And I'm going to multiply 8 times 9 and multiply that way. So 16 times 5, so I may have to work that out on the side, and that's totally fine. So 16 times 5. 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. So 16 times 5 is 80. Good. So I'm going to put this on top. Notice how the answer of that goes up here. And I'm going to do 8 times 9. So I'm going to go work this way. So 8 times 9 is, I know that to be 72. Now, what is greater, 80 or 72? 80 is greater. Therefore, the answer would be 5/8 is greater. And that's it. Okay, there's a lot more to it going on in the background, but for now, when you're comparing fractions, if you cross multiply, so let's say that you didn't know what the common denominator was, you didn't know what to multiply this by. If you just cross multiply, 16 times 5 gave me 80, 8 times 9 gave me 72. Just by doing that, so I put the answers on top of each. So 16 times 5 is 80, 8 times 9 is 72. Just by doing that, I can see that 80 is greater than 72, therefore 5/8 is greater. I got the exact same answer. Let's do another one. And let's do it using both methods. And you can decide which is easiest. All right. So B. We have 3/10 and 4/15. Now, if you notice, it's not as obvious what the common denominator is on this one, is it? It's not as obvious. 10 times nothing gives me 15, but if I multiply 15 times 2, which I have to multiply the 4 times 2 as well, that's going to give me 8/30ths, okay? And I know that 10 times 3 is going to give me 30, so I have to multiply 3 times 3 as well, so this is going to be 9/30ths. So I'm going to rewrite my fractions down here, so this is going to be 9/30ths. So I'm really comparing 9/30ths and 8/30ths. Oh, wow. I can easily see that 3/10 is larger because 3/10 is the same thing as 9/30ths, and 4/15 is less because that's the same thing as 8/30ths. Okay, that wasn't too bad, but I had to change both of the fractions. Now let's use the cross multiplication method. Okay, so let's multiply 10 times 4, which easy, that is 40. And 15 times 3, which should be easy for some of you guys at least. And if you don't, then just work it out. But I know that 15 times 3 is 45. Wait, isn't that the exact same answer that I got? That 3/10 was larger? Yes. So again, just by cross multiplication, one is not necessarily easier than the other. Sometimes finding the least common denominator is going to be easier, where you find where you change them to have the same denominator. Sometimes it's going to be really obvious and easy to do that, and sometimes it's going to be just a lot easier to just multiply them. But both methods work. Both methods work, and they will give you the same answer where they both apply. All right, so let's do C together. Let's do this last one. And I encourage you to pause the video and try this one on your own. So pause the video. And then let's keep going. So let's see, let's compare my answer with your answer. So here we have 21, 2/21 and 3/14. Now, I'm sure that you could probably find a common denominator somewhere down the road, but I can't think of one, so I'm just going to quickly do 21 times 3, which 21 times 3 is 63, I believe. And if you're not sure, then work it off on the side. 21 times 3. 3 times 1 is 3. 3 times 2 is 6, so that would be 63. Good. And 14 times 2, which is 28. So obviously, 63 is larger, so 3/14 is greater than 2/21. Pretty simple. Cross multiplication, a great method, or find the least common denominator and compare your fractions like that. Pretty simple. Okay, let's move on to number 14. Number 14 is interesting because they're asking us to draw these boxes or draw these rectangles and to shade a certain amount of that rectangle. So the first one, they want us to shade 3/4. The second one, they want us to shade 1/2. And the third one, they want to shade 7/18. And you know what I see when I see these rectangles, ladies and gentlemen? I see rectangular pizzas, of course, because I see pizzas everywhere. And you will too by the end of the school year. So the first one's 3/4. So let's go over here and let's make, so I'm gonna write down 3/4. That's not it. So let's shade in 3/4 of this pizza. So remember, I need 4 total pieces, okay? And that's not very, you can't see that very clearly. So I'm gonna make this a lot bigger. So this first one, okay? So this first one is gonna be 3/4. So that means that I need 4 total pieces. That means I need to split this into 4 equal pieces. And I think the easiest way to do that is to first cut it in half. So now I have 2 pieces, and then cut each of those into halves as well. And that's going to give you 4 pieces. And we want to shade in 3 out of those 4 pieces. So I'm going to shade in 1, 2, 3. So essentially, ladies and gentlemen, I have shaded in this much of the bar. Cool, awesome. And it's pretty close to scale because cutting in half was pretty simple. So the second one is, and I do want you to do this in your notebook, is 1/2, and that's going to be the easiest of them all, 1/2. So let me go over to my notebook once again, and let's shade in half of it, which is, again, super simple. And let's do it in a different color. Let's do it in red. And so again, just right down the middle, just like this one. So let's cut it right down the middle, just like we did that first one. And I'm gonna shade half of it. So there you go. I'm just gonna shade in half of it. 1, 2, 3. Or in this case, just 1. All right. And you can easily see that I've shaded it from here to here. Awesome. And finally, let's shade in 7/8. Let's shade in 7/8. Let's go back to our drawing. So 7/8. You might think that's hard to do, but it really isn't. Let's just, again, cut it in half. So right down the middle, just like we did these two. Notice how the half is always in the same place. That's why I put them like that. So half, half, half. And then we need 8 pieces. So 7 out of 8. And this second one was 1/2, right? So 7 out of 8. So let's cut it into 8 pieces. So that's 2. And if we cut these into halves, that's going to give me a total of 4 pieces. And if I cut each of those into halves, that's going to give me 8 pieces. All right, that's going to give me 8 pieces. Perfect. And so let's shade in 7 of those. Let's shade in 7 of those. And for the sake of time, I'm just going to go ahead and just do this. So shade all but 1. So as you can see, which one is actually bigger? 3/4, 1/2, or 7/8? Just by looking at this, I can easily see that 7/8 is the largest of all of these fractions. Notice that I didn't change the size of the pizza or the chocolate bar, whatever you want to think of these are. I didn't change the size. I just changed the number of equal pieces that I cut into each one. The first one was into 4ths, the second one was into halves, and the third one was into 8ths. And just by doing that, I was able to see which is the largest of these fractions. That if I were to put these in order from least to greatest, then it would be 1/2 is the least, 3/4 is more than 1/2, and 7/8 is almost the whole bar. It's the most. All right, ladies and gentlemen, I hope that this gave you an idea. Obviously, I didn't cover every single question, but I covered most of them, and I hope that this makes this assignment a lot easier for you. Remember to submit this. This is being done on a Friday. Submit it before the next class day, which from now is going to be on the Tuesday. And if you have questions, email me, message me on Schoology, and hopefully you'll be able to do that. Don't forget to take a picture of your notebook along with your notes, upload that to OneNote, and also submit on Schoology. Remember, you have 3 tries, and good luck with that. Y'all have a good one.